Hi everyone, my name is August Ramaputra, and today I'll be showing you a little bit about my project, Cast. So what Cast basically is, it is a video sharing platform, something like YouTube, and it also is a live streaming service, something like Twitch or Mixer. So before we begin, perhaps I can walk you through the process of uploading a video. First, we go to the profile page, then we'd go to Manage, and here we can insert the video details. Description here, and reorder the tags if you would. And I'll pick a thumbnail and we pick a video. As you upload it, you'd see that the video is in a process state. So every video being uploaded to our platform will be split into different qualities or resolutions from 240p, 360p, 480p, 720, and 1080p. So it enables streaming method called DASH, or Dynamic Adaptive Streaming over HTTP. And as we can see, the lowest resolution to 480p and 360p is done being processed. Perhaps we could see how Dash streaming works. So this is a video I've uploaded previously. Now this video is being played in highest resolution 1080p. As we can see with the segments being loaded, the videos are loaded in smaller segments, and each segment will be given number with a 1/6, or any number in between will represent the videos in their different resolution. Here, segment 1 refers to the video in 1080p, and segment 6 refers to the audio track itself. If we try to reduce the bandwidth and we might want to reset the buffer. As we wait for a bit, we will see that the segments being loaded are now segments 3 and 6 instead of segment 1, where segment 3 is exactly 480p video resolution. So this enables the video to be played flawlessly, regardless the available bandwidth. This allows a smoother playback. It is something like what you see on YouTube, that it adjusts the resolution being played depending on the speed of internet that you have. And some of you might have noticed that I'm actually streaming right now. So perhaps we could see that page. Yeah, right here. So this is the live stream. So this is currently live, and yeah, the chat works. Yeah, you can see the chat appearing on the video stream itself. So this chat is actually on the video stream. It is not laid over the video viewport. So to set up a live stream, what we do is we go to the profile page and we go to the dashboard. So this is where we manage our live streams. So perhaps for the current moment, we would want to end the stream and see how we set up a live stream. So first, you need to have an application or a computer. Usually people use an app called OBS, which enables you to stream your screen. First, you go to settings, then you'd go to stream. Make sure that we are streaming to a custom streaming server, and we need to insert both the URL and the stream key based on what our page shows right here, the server address itself and stream key. We put both of them respectively into their own inputs. Now, as I said it done, to begin a live stream, we need to first press go live here. So this enhances the security by only enabling live stream uplinks only if we open the window. Then now we can set to go live. Right there. That's simple. Now we are already live. You might want to change your stream description perhaps. That's where we do it. Now we are back to our live stream. Now I will show you how the components of the project is being tied together and how they connect to each other. So you can visit the repository page at gitlab.com/livestream/cast. And here is the list of the services. So the application is split into three parts: the backend, front end, and the transcoder service. These are how I codename them: cast BE, FE, and IS. The backend is using Golang with BGO framework and MongoDB database. The front end is using JavaScript with React.js, and the transcoder service uses Golang with FFmpeg for the transcoder. This is the architecture diagram. When people are visiting our page, cast FE, the front end, will serve the single page application content. And from that page, it will use both REST APIs and WebSockets to interact with the backend for loading content and for the live chats. And when a user uploads a new video to cast BE, it will inform all the other ingestion servers via a message queue. In this case, we are using Google PubSub. So when we are using message queue, we can set it up so that we can round robin, in a sense, multiple instances of other applications, and we can tell them to do something by sending a payload. In this case, we are sending a payload of a video tag for which this ingestion service will try to transcode them into the different resolutions for dash streaming. As you may have noticed, we have two of the ingestion servers. We can have more than two of these. It is highly scalable as we are using the message queue. And as we do that, the resulting videos will be put into our CDN, Google Cloud Storage. And from there, it is where our front-end page will load the video from. In terms of implementation, we can try to look at right now. So this is our backend. Perhaps we can see how the video transcoding works. So when a user uploads a video, it will do a series of tasks such as retrieving the video, it will try to normalize the thumbnail, and at last, it will transcode the video itself. So when it goes here, it will call a function to start transcoding, which is right here. And what it does is it will publish a message or a payload to our message queue, which contains the hash of the video itself. And this hash will be retrieved by our ingestion server right here, receive the message, and it will execute the command for FFmpeg, enabling it to execute a series of functions, splitting them into the different resolutions of the video. And on every step of the video's resolution being processed, it will send a message back to the main backend application right here, and that will inform our application that parts of the video has been done being transcoded. And this is what lets our manage page show the current resolution, the current latest resolution being processed. So that's how the transcoding works. Next, we might want to look at how the live streaming works. So here, this function, create RTMP uplink, is being called whenever the application or the backend application is being executed for the first time. I'm using a library Joy4 from Narix, and here we are defining a callback function when a publish call is being triggered by OBS. So here we are checking that the stream is currently opened as we set it in the dashboard, and once it does, and it's fully checked that the stream is ready to receive uplinks, this function, copy packets, will actually retrieve the uplink stream data and push it back to a queue. And this is where the video live stream is being played back later on from our front end. And if we look at our front end page, this is how the video player itself is being loaded. So we are using a library from Video.js. We are using this because it enables us to use the same player for both the live stream that we are using, FLV, and both that and the Dash streaming service. So we can simply just use this one component in React in order to load both the live streaming and the Dash streaming. Well, yeah, that is pretty much it from me in this presentation. This is our previously uploaded video. And yeah, thank you for your attention and have a good day.